right, period 3, you made it back. Sorry, period 3. No, you're period 4. You made it back. Okay. So anyway, I hope that went okay yesterday or Monday or no, Wednesday. I have no idea what day of the week it is. I hope that went okay for you. Just naming those different angles, and the homework went fine. Hopefully you checked your answers in the back of the book. I'll talk about the even answers when I get back on Tuesday with you. We're going to move along. I am assuming that you understand how to name those angles because we're going to move on and talk about parallel lines. Here goes my clock. So that is 1/2 hour. Okay, so we're going to draw 2 lines. We'll call this line A and this line B, and our transversal goes this way. Alrighty. So let's label our angles too. 1, 2, 3, 4, 5, 6, 7, and 8. So let's say angle 3 is congruent to angle 6. Let's say we know that to be true. Angle 3 is congruent to angle 6. What is the relationship between 3 and 6? What's the name? These are, they alternate, they're on the interior, so alternate interior angles. So if alternate interior angles are congruent, then if that's the case, then we have parallel lines. Then the lines are parallel. And the way we can show parallel lines is by using little arrows. So if this line has 1 arrow, this line will also have 1 arrow if they're parallel. Or if this line has 2 little arrows like this, then this one gets 2. So that's how I know these 2 are parallel when you're looking at a diagram, or if you want to draw it on a diagram, you draw it this way. Don't confuse them with tick marks. Remember, tick marks show congruence. The arrows show parallel, or parallelness, I suppose. So if alternate interior angles are congruent, then the lines are parallel. Let's think about another set of angles that are related. What about alternate exterior? So let's say looking at angle 2. If angle 2 is congruent to angle 7, so if angle 2 is congruent to angle 7, would these lines be parallel? Yes, they would. So if alternate exterior angles are congruent, then the lines are parallel. So we've got alternate interior angles are congruent, then the lines are parallel. And if alternate exterior angles are congruent, then the lines are parallel. How about, let's take a look at corresponding. So angle 2 corresponds to angle 6. So if angle 2 is congruent to angle 6, angle 2 congruent to angle 6, then we would have parallel lines also. So if corresponding angles are congruent, then the lines are parallel. Okay, so these are all going to be reasons that you can use in a proof, and I'll show you in a minute when we get to a couple of proof examples. All right, so that's the congruence. If your alternate interiors are congruent, alternate exteriors are congruent, or your correspondings are congruent. Now let's talk about the other relationships. So let's say 3 and 5 are supplementary. So angle 3 is supplementary to angle 5. So if these are called, they're on both on the left, so they're on the same side. If same side interior angles are supplementary, then lines are parallel. And then I'm sure you can figure out what the last reason would be that we could come up with. So if we looked at, let's say angle 1 is sup to angle 7. So if same side exterior angles are supplementary, then the lines are parallel. Okay, so you've got those 5. Make sure you have those 5 written down. We're going to utilize them. We're going to do a proof. That's exciting. We love proofs, right? Actually, maybe before proofs we'll do, yes, actually, I'm sorry, pull out worksheet number 1. Pull out worksheet number 1 before we get to proofs. Let's do this. So worksheet number 1 looks like this. I'm going to have you go through all of these problems, so 8 through 21. I'll do the first one or so with you. So, given the following information, determine which lines, if any, are parallel and state the postulate or theorem that justifies your answer. So angle 1 is congruent to angle 2. If you want to trace it, you can. So angle 1, angle 2. So those are corresponding. So since corresponding angles are congruent, lines are parallel. So I would write as my answer to that, where did I put it? I have an answer sheet here, hold on. Hold on. Put it on the back side? Nope. It's missing, that's okay. So I would say if, I would use another piece of paper actually, and say if, we'll do this here, number 8. If corresponding angles congruent, then the lines are parallel. All right, that would be the postulate or theorem that we use to justify. Now, which lines would be parallel? We need to figure that out too. Look at your drawing. Sorry, you probably can't see that. Look at your drawing. Which lines would be parallel in this case? It would be R parallel to S. Okay, so go ahead and work 9 through, let's do 9 through 15. Take about 3 minutes to work 9 through 15. Turn off the video and work 9 through 15. While you're working on that, I'm going to locate my answer key that I had made. And I will see you back here in just a minute. Found it. Okay, here we go. So, corresponding angles are congruent, then the lines are parallel. Number 9. If alternate, oh, you know what I didn't do though on my answer sheet was I didn't write down the lines that were parallel. So let's do that. We said R parallel to S in number 1, and then in number 8, and then in number 9 it would be U parallel to V. You like my fancy cursive? I'm doing the best I can. Okay, number 10. If alternate interior angles are congruent, then the lines are parallel. So they're talking about 5 and 7, so that would make R parallel to S. And number 11. If the same side interior angles are supplementary, then the lines are parallel. So that 7 plus 8 equals 180. It implies supplementary. And so the lines that would be parallel, R is parallel to S. Number 12. If the same side interior angles are supplementary, then the lines are parallel. So it's the same reason, but it's a different set. It would be 3 and 6. So the different set of lines. So you'd have U is parallel to V. And then number 13. If alternate interior angles are congruent, then the lines are parallel. And so that set of lines for angle 3 and angle 5 would be U and is parallel to V. And then 14, that's actually not a theorem. So this one would not work. There is no theorem showing that lines are parallel. Lastly, 15, if corresponding angles are congruent, then the lines are parallel. So you have 4 is congruent to 5, so that would make R parallel to S. Okay, so moving along to the next part of worksheet 1, you have to find x. So let's take a look at this guy. We've got to find x so that m would be parallel to n, and then we'll identify our postulator theorem. So notice that if you trace these guys, they are alternate exterior. So alternate exteriors would be congruent if we were trying to make those lines parallel. So you would set up your problem for 16. You would say 3x minus 14 equals 2x plus 25. Solving for x equals 39. I hope your Algebra 1 skills are still kind of sharp. And so then you would state if alternate exterior angles are congruent, the lines are parallel. That's how that works. Okay, so go ahead and shut off the video for a little bit. Probably need about 5 minutes or so to work through those the 6 other problems, and then turn it back on when most of you are done, and we can check our work. Okay, solutions then. Here we go, welcome back. Solutions. So for 17, x equals 25. If corresponding angles are congruent, the lines are parallel. For 18, x equals 63. If alternate interior angles are congruent, then the lines are parallel. Number 19, x equals 43. If the same side interior angles are supplementary, then the lines are parallel. And lastly, or not lastly, number 20. So there is actually no direct theorem for this, but if those two angles were supplementary, so x would equal 27, then you could have parallel lines, but there is no theorem to support that. And then 21, x equals 36. If alternate exterior angles are congruent, the lines are parallel. Okay, so you've worked on worksheet number 1. Now go and take a look at worksheet number 2. Worksheet number 2 has you asking you, okay, here are some values for some angles. Prove whether the lines P and Q are parallel or not. So these on number 1 are same side interior. So same side interior would need to be supplementary. So are these two angles supplementary to each other? The answer is 140 plus 40 is yes. So P is parallel to Q. So check your work on 2 through 8. Take I don't know, about probably less than 5 minutes to work on 2 through 8. You're going to show whether or not, now it says prove whether the lines, you're not going to do a full proof. You're just going to use the numbers to determine whether or not the lines are parallel. And then give a reason. Your reasons are the ones that we had talked about in our notes. So our reasons are here. So go ahead and give it a shot. Turn off the video for about 5 minutes, maybe a little less, and then come back on and we'll check it. Okay, welcome back. So number 1, the same side interior angles, oh gosh, is this the right one? Same side interior angles are congruent. Nope, same side interior angles are supplementary. So you've got parallel lines. Number 2, it is no, but you do notice that these guys are supplementary. So if I brought 124 up here to its corresponding location and these guys were supplementary, then it would work. But there is no theorem that would support that. Number 3, corresponding angles are congruent. 132 and 132 are congruent, so they would be parallel. Number 4 is no. Again, you have that situation where there is no direct theorem. If you brought the 25 up, then you would get 170, and they're not supplementary either. So this one's a big fatty no. Number 5, same side interior angles are supplementary, so this would be yes. So number 5 is a yes because same side interior angles are supplementary. 6, these guys here, well, there's no relationship to this line down here, so this you can't show anything other than, hey, 118 plus 62 is 180, yay, they're supplementary, but it doesn't talk about these lines. There's no angle on this line to refer to. And wow, there's a rainstorm outside right now that is unbelievable. Okay, number 7. You've got 75 and 115. Bring the 75 up here, you get 190. So again, these are not going to be parallel. And then number 8, you bring the 120 up or the 50 down, and you notice that they are not supplementary. They add to equal 170, so these are not parallel. All right. Next, let's do a little bit of, well, you did the algebra, so good job. Let's go ahead and do a proof or two, and then I can set you loose. So go ahead and pull out your notes that you've been working on. So they look like this. And we're gonna do a proof or two. Here we go. Oh, my clock's gonna go off again. Oops, I hit the camera. Okay, let's draw this picture. 4-sided. And it's P, Q, R, S. And the angles are numbered 1, 3, 2, and 4. You're given angle 1 is congruent to angle 2, and angle PQR is congruent to angle RSP. We are going to prove PQRS is a parallelogram. Did I spell it right? No, parallelogram. There we go. Parallelogram. In order to prove a parallelogram, we need to show that both pairs of opposite sides are parallel. So I'm going to write that in. Both pairs of opposite sides are parallel. That's really what I'm going to do. Show that both pairs of opposite sides are parallel. So let's go ahead and start. We are given, and I'm going to write it out, angle 1 congruent to angle 2, and angle PQR is congruent to angle RSP. And then let's go ahead and go to our diagram and put in tick marks. So angle 1 is congruent to angle 2. Well, wait a minute. Let's look at that real quick. Maybe trace it. If angle 1 is congruent to angle 2, I trace it. What kinds of angles are those? What's their relationship? They make the Z, so they are alternate interior. If alternate interior angles are congruent, then the lines are parallel. So which lines would be parallel in this case? You see them? These guys right here? Okay, so PQ is parallel to RS since alternate interior angles are congruent. Okay, so we've got a pair of parallel lines. And remember how to mark the parallel lines. We mark them with the arrows. So I'm going to put one arrow on each of those lines, reminding me that those are parallel. So one set of opposite sides are parallel. So I'm close to getting a parallelogram. It says both pairs of opposite sides have to be parallel. I've got one pair. I've got to shoot for the other pair. Well, we haven't even finished looking at the given yet. So we also know that PQR is congruent to RSP. Let's mark that. PQR, so this big one here, is congruent to RSP, this big one here. Okay, well those, if I traced those, they wouldn't make any kind of a letter. I know that one is congruent to 2, and the big one is congruent to the big one. So if I did a little bit of axiom 3, then maybe angle 3 would be congruent to angle 4. What do you think? Okay, so thus, by axiom 3 is congruent to angle 4. Okay, let's trace angle 3 and angle 4 and let's see if they give us anything. Angle 3 does this, and angle 4 is this. Oh, hey, look, there's another Z. Do you see the Z? The purple Z? But it's a different set of parallel lines. So QR would be parallel to PS. So QR is parallel to PS since alternate interior angles are congruent. And then let's go ahead and mark that. I'm going to use 2 arrows, double arrow and double arrow. Oh, hey, I just did what I wanted to do, right? I've got both pairs of opposite sides now are congruent. So therefore, PQRS is a parallelogram since both pairs of opposite sides are congruent. There we go. There is your proof, my friends. Okay, so now you're going to go ahead and work on worksheet number 3 and worksheet number 4. As well as, so when you finish those 2, you can get started on your homework. Your homework for the weekend is on page 219. You're going to work problems 1 through 5, 12 through 14, 20, and 21. So you have quite a bit of work to do. This stuff can easily be done in class, and these things you can get started in class if you finish 3 and 4. Help each other out, be good to the sub, and don't forget what's due on Thursday. Test corrections. Don't forget test corrections, okay? All right, I will see you next week. Have a good weekend.